Okay. We are learning 2.5. This is 2.5. No, it's not. It's 2.8. 2.8, which is about factoring. And if you notice now, we're factoring and our x squared is no longer x squared. It's 2x squared. It's 4x squared. So we call this our a, and our a is bigger than 1. So we're going to be factoring this. So we're starting on this problem here. You see where it is on your slides. I'll be going back and forth in there in a little bit. So it says, because she is a great business manager, Optima offers her customers lots of options. The option to have the rectangles that have side lengths that are more than 1x. An open version of one of these is below. So this is called a generic rectangle. I call it the array model. Sometimes I'll call it the box. There's a lot of different names for this, and it just organizes your information. So what do you notice about this, and what do you wonder? Can you look at this and tell me some of the things that you notice? What do you notice here about this whole thing? What do you notice here? Anything that you notice? I see what you guys put over here though. Yeah, it's 2x squared instead of 1x. One of your classmates says, very good. Someone else says the 2x plus 1 and the x plus 3 both equal 3x's. I'm not sure what that means. This one says the 2x squared, Miss Johnson, I see it. And then this one says, I wonder why in standard form, the side is 7x plus 3 when it's 8x plus 6. Should it be odd numbers? You guys are asking really good questions. There's more than 1x, exactly. Let's see what else other people put. This person put, oh, I noticed this, and they're starting to underline things, right? And if you understand what they're doing here, this 6x plus x is 7x. I understood your little markings there. Very good. A couple more people here. Oh, they noticed 6x plus x is 7x. 6x plus x, right, is 7x. Very good. Very, very good. Yeah, so all of those things are big. Those are a big deal. Okay, so let's continue. It says, use your observations to complete the diagram. Be sure to fill in the lengths of the sides and the missing areas. Okay, so let's start filling this in. Go ahead and take a second. This is 2.8. Take a second to look at this real quick. Okay, what do you notice? What can you put anywhere? Something here. So tell me something that you could put. Any of these missing places here, 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 here. What can you put anywhere? Up here, maybe over here. What's something that you can put? Let's look at what some of your classmates put, and maybe it'll tell me that I need more time. Miss Johnson, I need more time. Oh, we got some answers. Oh, interesting. Where'd they get all of this stuff from? I don't know. Oh, wow. Interesting. I don't know. Let's see, what else? Okay. So I noticed a couple of things, and some of these are not exactly correct, but that's okay. Can you guys all, wait, where's my notebook here? Can you guys all tell me, where do I put this 5x squared? Would it go here in factored form or here in standard form? Nice, very good. Would this 5x squared go here in factored form or here in standard form? Actually, no, this one goes in standard form. Standard form is inside, factored form is on the outside. Factored form, I want you to think of, this is in parentheses. Oops, I don't have a, this looks like this. That's what this is going to look like. Factored form is parentheses times parentheses, factored. So factored form means I can see my factors. I could see my factors. Got it? Okay, very good. I'm okay with you guys trying stuff out. Very good. So then, Ms. Johnson, you want me to put a 5x squared here? Yes. And then notice here, I'm missing something. So I'm going to leave a blank there, and I'm going to put that 3 there too. 5x squared, done. I don't know what goes there yet. and then I got a plus 3. Very good. Okay, and you're saying that I'm going to put some parentheses here and here, and that's what the factored form looks like? Yes. Okay. All right, so, what can I put? What can I put? What can I put where? Ooh, someone says, hey, Ms. Johnson, I know that 2x plus 3x is 5x. Okay, but I'm looking for, how do I know what goes right here and right here? So let's look at this guy really quick. Tell me what you see. Think about how we've been using this, and tell me how you know that this answer here outside, the length and the width, is correct for this area. How do you know this length and this width is correct for this area? So how do you know? How would you check your answers? Let's say during a quiz day, you had this here and you said, oh, this is its factored form. How would you check? How would you check? Yeah. So let's multiply out. What's x times 2x? 2x squared. What's x times 1? X. What's 2x times 3? 6x. What's 3 times 1? 3. So then when we're adding all this together, we get 2x squared plus 7x plus 3. That's what you all showed, yes? Okay, so now what I want to do is I want to apply that here, right? So I know that 5x squared goes there and 3 goes there. So now I'm looking for what times what can give me 5x squared. What times, yeah, so I'm going to put a 5x here on top. Now again, if you want to put the 5x here on the side, that's fine too. Okay. Now for this answer, because we weren't given all the pieces, there's not only one answer. Are you guys all okay with that? There could be more than one answer. I'm just going based off of what you said. Okay, wait, let me check. X times 5x. Yeah, that's 5x squared, Miss Johnson. Perfect. So can you imagine 5x squared? 1, 2, 3, 4, 5. Can you imagine my 5 squares in a row right here? Good. And then I have 3 here. So, okay. What times what will give me my 3? What times what? So then that gets 5x times x. Yeah, it's 3 and 1. Okay, now when I tell you that there's more than one answer, this is why this one will have more than one answer. Most of the ones that we do together won't have more than one answer. You guys all comfortable with that? Okay, very good. Very good. Good. Okay, good. Okay. Okay, so then I'm going to put a 3 here and a 1 here. Now, if you didn't put a 3 here and you put a 1 here, your answer here will be different. And your answers here will be different. So I'm going to put a 3 here and a 1 here. And then because I put a 3 here, what goes in this rectangle here? Yeah, 3x. Very good. Okay. And because I put all that here, what goes here? Get your answers in there. Don't depend on other people. Don't depend on other people. Okay, you have to answer this because you are the one taking this quiz. Yeah, 5x goes here because 5x times 1 is 5x, right? So I'm going to put 5x here. 5x times 1 is 5. Okay. 5x times 1 is 5x. Very good. So now what number goes here, though? What number is going to go right here in standard form? What number goes there? Yes, 8x. Very good. Now, why does 8x go there? Because 3x's plus 5x's is 8x's. 3x's plus 5x's is 8x's. Does that make sense? It's okay to be wrong in front of the whole class. Who cares? I'd rather you be wrong now. If you're wrong now, most likely you won't be wrong when. Very good. And now, Ms. Johnson, you said there could be more than one answer here. How come? Well, okay. So the reason why I can tell you there's more than one answer is I chose to put 3 here. And a 1 here. I put a 3 here and a 1 here. Now, if you flip-flop these, your answer here and your answer here will be different. That's because they didn't give me all these pieces. Now, for this one down here, they gave me all the pieces. Do you see all my pieces? Do you see all my pieces? Do you see all my pieces? Okay. So what I want you to do is I want you to try your own. I want you, I don't know why it's separated, but here and here. Can you try this one on your own? They already filled out part of it here and part of it here for you. I want you to fill out what these boxes could be and what these could be. Now, that helpful question that someone, I think Nathan, it was Nathan, what times what and what plus what will come back, but it's a different way to find those numbers. So I'm going to put that here in hopes that we can still use this question that he came up with. So right now, what I want you to do is try your best to fill this out. But look, I already have 7 X's. So that's a big deal. So I'm going to give you a minute to figure this out. Some of you already figured that out. If you already figured this one out, you can move on to another question. But let me pause and make sure that everybody got this. Okay, so I watched a couple of you do these, and a couple of you are a little bit like, ugh, how do I do this? So one way to do it is definitely playing with the numbers and then going back and forth and checking. Another definite way to do this is by using our tiles. And because you guys all got tiles, I'm going to draw it using tiles first. And that way you'll see. So this says 2x squared plus 7x. So I'm going to put 2x squares right here. So here's 1x squared. Here's another x squared. And I'm going to line them up just like this. And you can line up and down from each other. It really doesn't matter. I'm just going to do it this way. Okay. And then it says I need 7 x's, which is weird because now I have to line them up below here and to the right of here. Okay. Both of those. So I don't know how to break those up right now, but I'm going to go grab these 3 little ones. So let me use a different color for my little squares. And I'll go, here's 1 little square. And then I'll copy and paste this 3 times. Okay, so I'm going to imagine, now I could either arrange my squares this way, across, or up and down. So the very first thing I'm going to do is I'm going to arrange them across just because that's what I want to do. I don't know, maybe that'll work, maybe it won't. Okay, do you see how many X's I'm going to have to use to fill in here and here? Do you guys all see how many X's I would fill in here and here? Do you guys all see that? You guys all see that? Okay, so how many would go right here? How many do you see would go right here? Give me 1 second, guys. So do you see how many X's I would have to put here? Remember X's being those little rectangles. So I'm going to make rectangles. How many rectangles am I going to have to line up right here? Do you guys all see the little rectangles that I'm going to build? You guys all see them? Yeah, right here, I would need 3 of them. So I'm going to go 1, 2, 3. Okay, so there would be 3. Now I'm not even going to arrange the other side because you guys can all imagine these other ones. Actually, I will just so that you guys all see. Okay, then Ms. Johnson, you need X's down here because remember you said that we needed to make a rectangle, right? Yes, you need to make a rectangle. So I'm going to try to make these the same size as the other guys so that it's very clear as a rectangle. So how many would I need here? Yeah, I need 2. Okay, Miss Johnson, I made a rectangle. Yay. Okay, there's a but. What's my buts here? What is wrong with this picture? Anybody see what's wrong with this picture? What's wrong with this picture? Why am I arranging it? What's wrong with this picture? Anybody see it? Okay, do it. Let's check. Does it make a rectangle? Everyone says, Ms. Johnson, that looks like a rectangle, right? Okay, let's check the second thing. Does this represent this? Okay, Ms. Johnson, I see 2x squareds, right? Very good. Yes, very good. Yay, you guys got it. Yes, they don't equal each other. So Ms. Johnson, wait, what do you mean? Someone put in the chat why this doesn't equal this. Good job, ladies. Good job. Why doesn't this represent this? Look very careful. 2x squared, 2x squared. 3, 1, 2, 3. 3. Yeah, there's not enough x's. There's not enough x's. Here, Ms. Johnson, you're supposed to have 7x. Here you only have 5. Okay, so going back to the drawing board, and then let's take these x's out because I know that that was wrong. Let me move this like. Move this over here. Let me move these over here for just a second. Okay. Now, another way that I can arrange my 3 is not across, but which way? Because these are 3. I need to make a rectangle out of these 3 little ones. What else could I do besides going across this way? Instead of going this way, which way can I go? Yeah, I can go down. Okay, so Ms. Johnson, you want me to arrange these this way? Yeah, and I know it seems like it doesn't make a big difference, but it does. Okay, so if we were in class, you guys would all be touching tiles. Tiles would be on the floor everywhere. It's one of my favorite days, okay? Because we don't, then I use these drawings. Okay, so can you all imagine how many x's would go here? How many x's would go here? Yeah, there's 1 x that would go right here. Very good. Okay, what's my next question going to be then? What is my next question going to be? What is my next question going to be, guys? I asked you how many x's go here. Yes, how many are going to go here? Very good. So how many are going to go here? All together, sorry. All together, how many are going to be here? Yeah, 6 of these. So you want me to draw 6 of these? Now, normally I'm not going to draw all 6, but because I really want everyone to see what we're actually doing and how it connects to what we did before. Does everybody see how I still make a gigantic rectangle? Yes. So then I'm going to transfer this information over to here. Okay, I'm going to transfer this information over here. Very good. So, okay, 2x squared, check. What do I put right here? Yes, 1x. Oops, that's a highlighter. Sorry, that's x, right? How many do I put here? 6x. All right, here's where I need you to pay attention to. Okay, so number 1, you using tiles, not a new thing. You playing around until you get a rectangle, not a new thing. This next part is new. So I need everybody to glue their eyeballs to my screen. I need everybody to say shh in your household so that you can pay attention, because it's one question and then the rest of it makes sense. Okay. I've taught this for years. One question. Okay. The very first question that I want you to ask is, I want you to look at this first row here. This first row here. And I want you to ask yourself, here's the question. Ready? Let me ask this question using my big, gigantic font. Here's my question. What is the biggest thing I can take out of both? Also known as the greatest common factor. Okay, what's the biggest thing I could take out of both in the top row, right? What's that biggest thing? What's the biggest thing I could take out? Oh, someone said X. Very good. It is X. In this first row, it's X. Now, someone says, hey, Ms. Johnson, can I take a 2X out? Can I take a 2X out? And I say, no. You tell me why I can't take a 2X out. Why can't I take a 2X out? Exactly, because this X doesn't have a 2X. This X doesn't have a 2X, so I can't take it out. Okay, so you just wanted the thing that I can see out of both of them? Yes. Now you can continue this way and going through this row and saying, okay, in this column, what's the biggest thing you could do here? And you could do that here and here, but I like to play who's missing. So I say X times what gives me 2X squared? X times what gives me 2X squared? X times what goes here? Yeah, 2X. Very good. Okay. So then X times 2X gives me 2X squared. X times what gives me X? X times what gives me X? Yeah, you guys are all fast forwarding now. You guys are like, Ms. Johnson, we get it. X plus 1. Exactly. Then what would go down here? 2 times what gives me 6X? 3. Okay. And if you notice, that's exactly what we got over here. This is 2X's plus 1. This is X plus 3. Ms. Johnson, it's the same thing that we used to do before. Exactly. The only thing that's different here is that we have 2 X's. Okay. So I'm going to pause again. I'm going to have you guys try these two, and then we'll come back and we'll make sure that you understand how to do both of these. Okay. So go ahead and work on 6 and 7. Okay. So I'm going to show you these, and I'm going to kind of use tiles, but at the same time, know that it doesn't matter in terms of negatives and positives. You do have to make sure that you're adding them correctly in order to get that. But the tiles will always help you. And the reason why tiles work is because it's a physical representation of what you're doing. Okay, so if I was going to do this one, 2X squared, so I grab my little squares and I go over here. Maybe I'll go to the left so it doesn't crash into each other. So I'm gonna do 2X number 6 over here. So I go here and I give me another one. Now some of you are like, Ms. Johnson, you have to line them up to the left and the right. And because you think that, I'm gonna go this way just so that you see it doesn't matter which way you go. And then I have 15 of these little squares. Okay, so I'm gonna just take a bunch of them. And there's no difference between these colors, so don't like, oh, Ms. Johnson, pink means negative. So can you imagine 15 of these guys? And think about all the different ways that I can arrange 15, okay? I can arrange them all in a row like this, so 15 little squares here. I can arrange them 15 in a row this way, and then I can arrange them in a couple other different ways, and then you'll understand the relationship between them. Okay, so someone says, Ms. Johnson, this is a lot of different arrangements to do. How am I going to figure out which one to do? Okay, so the first thing that I notice is that I have negative 13 X's, which is a lot of X's. So I am going to, I'll just try this way. I'm going to try arranging these like this first. Oops. I'm going to grab all these and I'm going to put them all in a row and see if you guys like see what I see. Okay, so I go like this. Oops, I shouldn't have done that. Okay, there. And then I go like this and I arrange them. And do you see how many times I'm going to have to do this? Pretend there's 15 of these, okay? If there's 15 of these going down this way, how many X's am I going to have here? How many X's am I going to have here? Exactly. Oh no, you have to make these rectangles. No matter what, these little guys need to be in rectangles. Yeah, there'd be 15 X's here, which is really annoying to do. So I'm just going to write it just so everybody sees. I have 15X here. And then do you see how you would have 2 X's here? 2 X's here. And so if you can imagine, you're like, hey, Ms. Johnson, but there's a negative there. Yeah, so you can imagine that this would be X minus 1. And this would be 2X minus 15. But this would be negative 15X and negative 2X. And that's not negative 13X. That's not correct. Okay. And so I'm hoping that you're getting a lot frustrated, like, Ms. Johnson, this is taking too long. So in that frustration, you're supposed to look for the pattern, okay? So then if I went this way, so if I arranged my tiles this way, a big long row of them, right? Then this would go away. And then I'm gonna pretend that these all don't exist right here so that I can, so imagine that I had 15 going this way. So 15 of these like ... this way. Can you imagine me arranging them this way? So if I had 15 this way, how many X's would I have here? How many X's would I have on top of this to make a rectangle? Do you guys all see that? I see Nathan sees it. Yeah. How many? So if there's 15 squares in a row like this, there would be this row of X's and this row of X's. How many all together? How many would that be all together? So this would be 30 X's, right? You guys all see that? So, and then I'd have like 1 X here. And correct me if I'm wrong, that does not give me a 13. So that's incorrect too. So I'm like, back to the drawing board. And hopefully you guys are getting really frustrated. Like, Ms. Johnson, just tell us. And you don't be better than just to tell you. Okay. So how else can I arrange 15 into a rectangle besides 15 by 1 or 1 by 15? Yeah, I can go 3 by 5. Okay, so if I did 3 by 5, right? You guys all see my 3 by 5 here. So can you start filling in the boxes over here while I do this? Can you start filling in these boxes over here? Okay. So how many X's would go here? How many X's would go here? Yeah, 3 X's. And how many X's would go here? It would be 5 times 2. Yeah, that would be 10 X's, right? And you're like, hey, Miss Johnson, 3X plus 10X is 13X. I think you found our answer. And I say, oh, okay. Well, let's see. So, okay, so then 2X, because imagine this is guys on the outside, 2X times what would give me 10 X's. 2X times what would give me 10X? What number goes here? X. Yeah, -5, right? And some of you are like, Ms. Johnson, where'd the -5 come from? Well, because I want negative 13X. So technically I want a negative 10 and negative 3, right? So then X times what gives me negative 3X? And then you're like, oh, that's negative 3. Okay. So then here's my answer. It's 2X minus 3 and X minus 5. Ms. Johnson, there's got to be a faster way. There is. And it has to do with the relationship. Hold on, let me show you this. This has to do with the relationship of a couple numbers that we had talked about earlier. So for sure we go 2x squared and for sure we go 15, correct? So do you remember this phrase that one of our classmates did? It was what times what gives me -9 and what plus what gives me 0. Well, the what plus what for this one is definitely going to be -13. Oops, not 0.13, sorry, -13. But this part here, the multiplication, that's where I don't know what number to put here. And I'm going to look at these numbers here. What times what gives me what? What am I looking for? What was the product that I was looking for? And I will show you where this comes from. So here, the numbers that we got were 10 and 3. If you think about the other numbers that we got, here, I'll show you them, and maybe you'll see the pattern. We got 10 and 3, remember? And then when we lined these up the other way, when it was 15 here, I think there was one that was 30 and 1. Do you remember that? When we had these all line up this way, we also had 30 and 1. And then we had another one when the 15 was like all in a row this way, it was 15 and 2. What do these pairs, what do these factors remind you of? That's another hint for you. What do these factors remind you of? What do all of these have in common? What times what gives me, wait, can you multiply these really quick? What do all of these give you? Hey, you just stopped paying attention. Pay attention. This is the key part. Glue your eyeballs. But what is that number? What is the number? When I multiply these, what do I get? Oh, I get 30? Oh, yeah, because all of those factors were all 30. So what times what gives me 30? Ah, man, I don't see a 30. Does anybody see a 30? Can anybody make a 30? Can anybody make a 30? Where do you see a 30? Anybody see a 30? Because if you find this 30, then we're done because we can use Nathan's trick every single time. Where do you see 30 here in this problem here? Where do you see 30? Someone's like, Ms. Johnson, I don't see 30. Good. Make a 30 with the numbers that I gave you. So imagine this is why math is a puzzle to me. So somewhere here, there's a 30 and you're going to take the numbers and you're going to do something to them to make a 30. Exactly. Someone found it. Someone found it. I'm going to find my snipping tool. I know I get so excited when you guys figure it out and I don't have to. Yeah, actually 3 people found it. So I'm going to snip all 3 of you. So, and then let me redact your name so no one sees who said it, because we don't want the interwebs to know who it was. I know, because I like Miss Johnson. Because I just don't like people knowing your guys' names. It kind of freaks me out. Okay. All right. So look, a bunch of your classmates said it. This is where you get the 30 from. Dun, 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 dun. 2x times 15. Oh, that. Okay. So I'm going to give you a physical representation of what we're doing here. So the very first thing I think about is I call this the X box and I multiply A times C. So that in this case, oops, let me write this over here. Sorry, move this over here. And then let me move this part. Oops, this part up a little. Oops, that's not what I wanted. I want this whole thing to move. So in this case, that's 2x squared times 15. And so you guys were thinking of 30x squared. And then on the bottom, I want you to put that middle number. This is B, so negative 13x. So here goes his question right here. This is his question. we're going to ask, right? So I'm asking what times what gives me 30 and what plus what gives me negative 13. You guys figured out that it was negative 3 and negative 10 because the way it happened is none of these will give me a negative 13 except for negative 10 and negative 3. So negative 10x and negative 3x. And so that negative 3x and negative 10x is what goes over here. That's what goes right here. Uh-oh, it's not catching up to me. Hold on. Computer, I'm being very patient with you. Okay, I'm going to pretend that it says that. Okay, pretend that it says, let's see, negative 10x and negative 3x. Can you guys all imagine that this says negative 10x and negative 3x? And then we're going to do what we asked up here. I'll move this over a little so everything's not crashing into each other. Okay. All right, there it goes. It's catching up, y'all. It's catching up. Yay, caught up. Let me just sync anyway. Okay, so here now I want to ask that question. What's the biggest thing I could take out of both of these? Here goes, guys. What's the biggest thing I could take out? And you guys would be like, 2x, Miss Johnson. And then the rest of this, you guys know how to do. Okay, so 2x times what gives me 2x squared? Very good. 2x times what gives me negative 10x? And x times what gives me negative 3x? Oh, that's negative 3. Okay, so I'm kind of rushing here. Here's your answer for that one. I want to do this one from start to finish using our X and our box. So I usually call this the X box. Other people call this the diamond method. Either way you do it, I want to go through and make sure that you understand how to do this. So the first step is this guy over here. So that's what I'm going to do. So who am I supposed to multiply together? Who am I supposed to multiply together? A times C. Oh, the first guy times the last guy? Yeah. So what is that? What's A times C? What's A times C? Yep, it's negative 30. So I just keep the x squared in there. And if you want to fill out the box right now, you can. So I'm going to do that too. 3x squared, and I get minus 10. So negative 30x squared goes on the top. And then on the bottom gets what? What number goes on the bottom? Oh, the bottom is B. Oh, the middle term. Yes. So 1x, Miss Johnson? Yes. And then we ask this question, right? I'm going to copy this again because I like doing this. Here. And so I asked this question. So instead, this time it says, what times what gives me negative 30, but what plus what gives me positive 1? So you're looking for here, what's a factor? What plus what? So did I find all my factors? 1 times 30, 2 times 15, 3 times. There's a factor missing. What's another factor of 30? What's another factor of 30? Come on, y'all. We got this. Yeah, it's 5 and 6. Okay, Miss Johnson. So you want me to write 5x here and 6x here? No, because actually that's wrong, right? Because 5x times 6x doesn't give me negative, hint, hint, 30x squared. So Miss Johnson, how do I know which one to give the negative to? Well, that depends on if this guy, so 5x, so it's either going to be 5x plus negative 6x or negative 5x plus 6, but I want a positive 1. So when I add these two together, I need this to be a positive 1. Yeah, so this one's negative 5x. Very good. Okay, so wait. First times last gives me that. Bottom gives me that. Ask this question. Okay, so but what do I do with this and this? Where do I put this? Yes, very good. Where do I put this? Where do I put these two? I'm going to take 6x. I'm going to be really lazy. I'm just going to take it. I'm going to copy it. But where am I going to put it? Here. Okay, see it? And then I'm going to take this. And I'm going to copy this. Ah, I copied too much. I'm just going to write it because I'm not that lazy. Okay, so I wrote negative 5x here. And then we're going to do this thing. So this is where I'm going to pause you and I'm going to have you guys go. But I really want you to try using this X box. So look at this here. Okay. Good job today.